Welcome to today's episode. The sole aim of this is to make sure we give you a detailed explanation of real JAMB questions in physics, so that in case you see it as you prepare for this forthcoming exam, or in case you see it in your examination hall, you will remember what to do and you get the right answer. If you are joining us for the first time, don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. So with no further ado, let's get right into the video. A block of mass 2.0 kilograms resting on a smooth horizontal plane is acted upon simultaneously by two forces, 10 Newton due north and 10 Newton due south. The magnitude of the acceleration produced by the forces on the block is what? Okay, so look at the options provided. Option A is 0.10 meters per second square. Option B is 7.07 meters per second square. Option C is 10.00 meters per second square. And option D is 14.10 meters per second square. So let's see what we can do to be able to solve this problem. So let's go. The question says a block of 2.0 kilograms. So that becomes the mass. So if you are solving any problem in physics, you should look at the terms given. That is the units attached to any value. Do you understand? So that kilogram is a unit for mass. So once you see that 2.0 kilogram, that stands for your mass. Okay, so let's go. We have mass equals to 2.0 kilograms. Okay, now it's being acted upon by two forces. It's being acted upon by two forces. One is going 10 Newton due north and the second one is going 10 Newton due east. So let's use an illustration to explain what we mean. So we have this. Okay, so this is 10 Newton due what? Due north. So north is up using the four cardinal points. Now this is north, this is east, this is south, and this is what? West. So if the question says 10 Newton due north, I'm just going to go to the north straight. Okay, that is what I have. Then from the same point we have 10 Newton due east. Now this is the 10 Newton due, this is on the east. So I have 10 Newton. Do you understand? We are asked to find the acceleration A. Now we are looking for acceleration A. That's what we are looking for. But we must remember that there's a relationship connecting the mass, the acceleration, and the force. So that is F is equals to M what? A. You now get it now. So you can't solve for acceleration without looking for the force. Now which force are we looking for? The resultant vector. The resultant vector, because these two vectors are inclined perpendicular to each other. Simply we're going to use Pythagoras theorem to get the resultant vector. Whatever thing we have, we're going to put it here. Do you understand? To get our acceleration, which is what we are actually looking for. Okay, let's go. So we decide to resolve it going this way. Okay, now we are just looking for the resultant force. This is the resultant force. Using Pythagoras theorem, which states that what? Hypotenuse square is equals to what? Opposite square plus adjacent square. Now we have two triangles. We are not actually solving for vectors, but I just want to explain the way you understand. We have two triangles. We cannot solve with the two triangles meshed together. So you have to remove one or extract one and solve with only one. I hope it's clear. Okay, so we have this. If I decide to solve with this, I have this. Okay, now this is my what? R. Okay, this is my 10 Newton. This is my what? 10 Newton acting up. Now this is my right angle triangle. So remember that you're not looking for the angle, but in case you're looking for the angle in another question, you can use this for the angle. Do you understand? Now using Pythagoras theorem, so we're going to say that this is the hypotenuse, the longest side. Okay, that is the what? R square is equals to, the opposite to this angle is 10. That is 10 square plus adjacent is equally what? 10. So let's go. We have R square is equals to 10 square is what? 10 square is 100. Okay, now remember 10 squared is the same thing as 10 times 10. Anywhere you see square, it's something as saying that number twice. We're going to give you the same thing as being squared. Okay, now plus, this is what? 100. So let's bring them together by saying r square is equals to 200. Right? Now let's get the root of this. Root of 200. Now what do we have? We have 1.414 Newton. Now this one we just got now is just for the resultant force. We've not gotten the acceleration yet. Now we're going to use the value obtained to put it here to solve for our acceleration. I hope that is clear. So let's solve. We say that F is equals to ma, right? So my resultant force is gotten as 14.14. So I have 14.14 is equals to, what's my mass? In the question is given as 2 kilograms. So this is 2 multiplied by what? A. Okay. Now this is 14.14 is equals to 2a. Because we're looking for the acceleration, we divide both sides by what? Coefficient of a, which is 2. Okay. So divide both sides by 2. This cancel this. So my a is equals to 7.07 meters per second square. Is that clear? Now from what we have gotten so far, the correct option to this particular question is option B. Is that clear? So let's go to the next one. Find the tension T1 in the diagram below. That is the diagram we have on the board. If the system is in equilibrium, okay, we are given acceleration due to gravity G to be 10 meters per second square. So it means that we're going to use this diagram to solve for our tension T1. Do you understand? So we are given the following options. Option A is 200 over root 3 Newton. Option B, 100 over root 3 Newton. Option C, 300 over root 3 Newton. Option D, 100 Newton. So let's see how we can solve this particular problem. Now, solving this problem, one thing that will come to your mind is this. They say these three forces, they are in equilibrium. Now it will lead you to the principle of triangle of forces, which states that if three forces are in equilibrium, they will be represented in magnitude and direction by the adjacent sides of a triangle taken in order. So what that principle is trying to tell us is this. They are going to represent this diagram on the board, use it to form a triangle by following the direction of this triangle. Do we understand? Okay, let's go. Now this is the weight. The weight of the object is given as 10 kilograms. But remember that weight is measured in Newton. Now because we are given G, so we can say that the weight is equal to what? Mg, right? So that is 10 times 10. We have 100 Newton as the weight. So this will now change to be what? 100 Newton. Do we understand? So the second step you're going to take is to resolve it to form a triangle using the principle of triangle of forces. So how do we resolve it? Watch out and see what happens. We're going to start with the tension T1. It is on a horizontal direction and it is moving this way, right? So let's go. Now I have, this is T1, right? Now look at this 100 Newton is acting downwards. So we go from the same point, we now go down. Don't mind my drawing. So we have 100 Newton, right? Now look at T2. Where is it going? It's going this direction. It's going this direction, okay? So from the same point I go this way. This is my T2 acting up, okay? Now you must remember that T1 and the 100 Newton, they have an angle called 90 degrees. Resolve here. So we have this. Okay, now look up again. T2 makes an angle of 30 degrees with the vertical. So you are going to have 30 degrees here. Do you understand? So we are done forming a triangle and this will help us to get our T1. I hope that is clear. For us to solve, you should know that this angle is missing. I can call this x. The sum of angles in a triangle is equal to 180. Now if this is 90, this is 30, this becomes what? 60. So let's work it out. I will say 90 plus 30 plus x is equal to what? 180, because the sum of angles in a triangle is equal to 180 degrees. So this is going to give me 120 plus x is equal to 180. Okay, Now x is equals to 180 minus 120 is equals to x is equals to 60 degrees. Now this is the angle here, so we can change this our x to be 60 degrees. Now that we have changed our x to be 60 degrees, let's now come to your mind is this to use sine rule. Okay, so using sine rule, right? This says that what a over sine a is equals to b over sine b is equals to c over sine c. Do you understand? Now let's relate it to what we have. This small letter a is the side of the triangle, while this is the angle inside the triangle. So let's go. Now we can decide to start with any one. Now this is 100 Newton. The angle facing it is 60. So this becomes what? 100 sine 60, right? Then is equals to, we have T2. Okay, let's go with T1. We have T1. The angle facing it is angle what? 30. So I say T1 over sine 30, right? Then is equals to, we have T2 over what? Sine 90. So this is T2 over sine 90. Now since our interest is just to get our T1, we are going to equate these two to get what you are looking for. So let's go. 100 over sine 60 is equals to T1 over sine 30. Okay, so simply by saying cross multiply, T1 is equals to 100 sine 30, then divided by sine 60. Is that clear? This is T1 is equals to 100 sine 30 is 0.5 or 1 over 2, right? You can say multiply by 0.5, right? Divided by sine 60 is root 3 over what? 2. Okay? By the time you multiply all three, you are going to have 50 times 2 over root 3, right? By the time you multiply, the answer becomes 100 root 3. Okay? So let me read it. I will say that what? My T1 is equals to 50 times 2 over root 3. You multiply, is going to give me 100 over root 3 Newton. Is that clear? Now from what we've got so far, the correct option to this question is option B. I hope that is clear. So let's go to the next one. A string of length 4 meters is extended by 0.02 meters when a load of 0.4 kilograms is suspended at its ends. What will be the length of the string when the applied force is 15 Newton and we are giving G to be 10 meters per second square, alright? So listen to the options. Option A is 6.08 meters, option B is 5.05 meters, option C is 4.05 meters, and option D is 4.08 meters. Now the question says a string of length 4 meters. That means the length of this string is what? 4 meters. We have our L to be 4 meters. Okay, now extended by 0.0 meter, that becomes the extension. Okay, so this is my extension E to be 0.02 meters. All right, so when a load of 0.4 kilograms, that is the mass of the load, is giving us 0.4 kilograms, right? Okay, what will be the length when the applied force is 15 Newton? Now we are given G. They give us applied force, that should be the second force, is equals to 15 Newton, and you are giving G to be 10 meters per second square. Do we get it now? Now from what I've gotten so far, this is what? This is the first extension and this is the original length. I'll write what? LO. Do we get it now? Now we don't even have the first force. Let's solve for the first force because they're giving a load of mass 0.4 kilograms. So my F1 is equals to M1G. Okay, so F1 is equals to my mass is 0.4 multiplied by 10, which will give me 4 Newton as my F1. So before we can solve for the new length, we must get our what? Force constant, which is K. Using Hooke's law, this is Hooke's law question. So using Hooke's law, so we say that F1 equals to KE1. Do you get it now? So the force we are going to use is 4. So this is 4 is equals to K. My E1 is 0.02. Okay? So we divide both sides by 0.02. 0.02. This cancels each other. K is equals to 4 divided by 0.02. Okay? So when we divide, it's going to give us what? 200 Newton per meter. Now, this same K is going to be used to get the new extension. That means that F2 is equals to KE2. That's the new extension we're looking for with our new force, okay? So our new force is given in the equation as 15 Newton. Now, this is 15 Newton is equals to, my K is 200 multiplied by E2. We have that E2 is equals to 15 divided by what? 200. So it is going to give us 0.075 meters. Okay. Now for us to get the length when the force applied is 15 Newton, we are going to add this extension to the original length. For us to get the L2, we are going to say that this is L0 plus E2. Is that clear? So my new length is equal to, my original length is given as 4 plus 0.075, which will give me to be 4.075, approximately to be 4.08 meters. Is that clear? And from what we've got, the correct answer is option D. In the figure below, the work done by the force of 100 Newton inclined at an angle of 60 degrees to the object dragged horizontally to a distance of 8 meters is what? So I'm going to use this diagram on the board to explain this work done question. Is that clear? So we have the following options. Option A is 600 joules, option B is 800 joules, option C is 400 joules, and option D is 100 joules. Now simply, let's look at this. This question is under work done in an inclined plane, okay? So we can draft out what we have here. Now the distance covered from the question is what? 8 meters. So using the formula for work done. Now this force is inclined at an angle called 60 degrees. And this is horizontal component of this vector, okay? Now horizontal component of the vector goes with cos, while vertical goes with sine. So since you're dealing with the horizontal component of this vector, and for work to be done, we must make respect of the angle because it is inclined. Okay, so the work done is equals to F cos theta times distance. Okay, now from the question, the force is given as 100 Newton, then the theta is given as 60 degrees, and the distance is given as 8 meters. Simply, let's substitute what we have and get our answer. This is very, very simple, okay? So let's go. We have the work done is equals to F cos theta multiplied by distance. Now, what is my force? My force is 100. Now, this is 100 cos 60 multiplied by what? 8, okay? Now, this is 100 multiplied by, what is cos 60? Cos 60 is the same thing as sin 30. You should know that special angles. So this is multiplied by 0.5 multiplied by what? 8. Alright, so let's go. This multiplied by this is going to give me 50. Now this is 50 multiplied by what? 8. Okay? Now by the time you worked it out, you have that the work done is given as 400 joules. Is that clear? Hope this one is simple now. And from what we have got, the correct option to this question is option C. Calculate the work done when a force of 20 Newton stretches a spring by 50 millimeters. Option A, 1.5 joules. Option B, 2.0 joules. Option C, 2.5 joules. And option D, 0.5 joules. Now, the first thing that will come to your mind is that this is the work done in an elastic spring, okay? Now, let's see what we can do. What is the force and what is the extension? So let's go. Now we have the force to be 20 Newton. Then the extension is given as 50 millimeters. Okay, to convert millimeters to meter, because we can't solve with extension being in millimeters, there is need for us to convert. So to convert millimeters to meter, we simply divide by 1000. So let's go. We have extension is equal to 50 over 1000. Okay, now this cancels this, so my extension is equal to 0.05 meters. Hope that is clear. Now there are two formulas we can use to get to the work done or even energy stored in an elastic string. So there we have work done or energy. Why I included energy is because they are still the same thing with the same formula. Now this is half Fe or half Ke square. Now from what we have, this is the values that we have provided. But in case in another question you see this K as first constant, so you're just going to use the second formula. Do you understand? But any of them can go depending on the parameters given in that particular question. So let's solve. I'm going to use the work done is equals to half Fe. Now this is 1 over 2 times, what's my force? My force is 20 multiplied by 0.05. Okay, now let's see what can divide. 2 can divide itself 1. 2 can divide 20. I have what? 10, right? Now this is the work done is equals to 10 multiplied by 0.05. Now automatically this one cancels one of these, so my work done is equals to 0.5 joules. Do you understand? So this one is quite simple. In case you see something similar to this, so this is how you can solve it. Remember, if you have the first constant, which is K, we're going to use the second formula. Do you understand? From what we've got so far, the correct option is option D. If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can see it and learn from there. And remember, I will not rest until you score 90 and above in physics. I will see you next time in the next episode. Bye for now.